Hello, everybody. Thank you for coming. Today, would like to share with you at least a part of a course I have prepared for students in Kiev University, which might be useful and interesting for many of us. For me, in particular, it was quite useful and interesting to go into details of how to program in Psychtoolbox and uh, what is the easiest and the optimal way to create an experimental paradigm. And as it is demonstrated on this image, it is really simple. Uh, there are three main domains which with the Psychtoolbox uh, can be manipulated quite efficiently and in a very simple way. First of all, we manipulate the timing. We set certain delays between our conditions, and we measure precisely the current time with those functions. Then, obviously, in any kind of experimental paradigm, we need to show something on the screen, and there is a large variety of operators which are typically started with the word screen. This is the main of the name of the main function, while the flags after it indicate specifically what do you want from the screen. Do you want to create a window, you draw some text on the screen, you make texture, you expose the texture, or you simply flip the screen, you refresh what is shown on it. I will speak about it later in more detail. And lastly, but not the least important, you need to acquire responses, and typically it is a keyboard. It is not super high temporal precision, but at least those functions, which are indicated here, they allow to be at the maximum precision given the limitations of the apparatus of the keyboard of the personal computer itself. Time is really critical for all of us, and one of the most traditional and well verified domains of human neuroscience is mental chronometry. And therefore, we need to learn how to measure time and how to set intervals between our conditions. And therefore, we can examine some functions available in MATLAB or GNU Octave without any Psychtoolbox, which can do pretty well the job of setting and measuring time if you don't need sub-second precision. While in Psychtoolbox, after it is installed, you have specific functions which are more precise than the default MATLAB functions. In fact, we can easily compare two options: the MATLAB functions used for timing and the Psychtoolbox functions. Simply by copy pasting this, which will be available to everybody after the talk, to MATLAB window, you will be able to measure time once and assign the first measurement to the variable of t1. Sorry, I will remove everything from the workspace so that it is easier to figure out what we are doing. Here it is. So this function clock, it measures current time and indicates it here in the variable t1. You can type t1 in the command window and it will give the content, the year, the month, the day, hour, minutes, seconds. Then with this function, pause, you ask MATLAB to wait 100 milliseconds. And then you measure the current time, the second time. And then using function eTime, you can estimate a difference, which is this one. As you see, it is not exactly 100 milliseconds. And if you do the same many times in a loop, you will be able to see the variation between measured time intervals while you always ask exactly the same. To make a pause of 100 milliseconds. Let's try this. Oh, now it's done. And we have this variable t where we store all the intervals which has been measured. Let's plot it. It's very easy. You simply write plot of t. With dots instead of a line. So those are time intervals between our iterations. How do we measure the variation of the duration of those intervals? Quite easy. We can use function diff, which calculates a difference between the first and the second and the third, and so forth. And here what we have shows clearly, well, maybe we can even something like this. Sorry. This is the variation about plus minus 10 milliseconds, which is the result of the timing functions which are available in MATLAB. What can we do instead is this, the Psychtoolbox functions. Here we use getSex for measurement of the current time and waitSex for the pausing. It is done, and now we can run exactly the same command for plotting the variation of the timing. As you see now, the variation is 10 times less. It is about 1 millisecond. And it is good. Absolutely. Because the precision of the functions is different, and it is better in Psychtoolbox. I cannot tell you more about the internal mechanism because I'm not a programmer at all. I just know how to compare those two and how to convince you that it is a good thing to use Psychtoolbox. So this is basically the same as what we have done already. For the keyboard, which is used to respond to most of the experimental conditions, you can use a variety of functions available in Psychtoolbox. And they are different in what they specifically do. KBCheck is the most basic function to check the current status of the keyboard. The other one, KBWeight or KBStrokeWeight, they are slightly different, but basically they do the same thing. Those functions, once they are started in your script, they wait until the key is pressed or unpressed, and then they release the flow and the program goes on. And the last one is using, well, both of them are using KBCheck. KBCheck is the most basic of them. But this one is designed for the most precise measurement of keyboard responses in an experimental setting when only a single or few keyboard presses are expected. What this function does and why it is better than KBCheck, it creates a queue, and this queue is started at a certain moment of the execution of the script. Once it is started, it functions on the background. And at the same time, you can do many different things. You show images, you run videos, sounds, whatever you want to do. There can be many different processes. And during all this time, this function is listening to the keyboard. And as soon as a key is pressed, the time and the name, the code of this key, is recorded and stored. And then, after you want to collect the data, you run KBQueueXXX. This is a very important subfunction of this family, and it retrieves for you all the information about what happened during this span of the time. KBCheck doesn't work this way. KBCheck has to be executed many times, and typically, if nothing happens, it gives zeros. I think I illustrated this on the next slide. Yeah, this is KBCheck. It's a bit of syntaxes. You run it, and it gives you a number of outcomes. Key is down, 1 or 0, at the moment of the execution of the function. Typically, it is 0 if nothing happens. Sex is the time of the key press, when exactly this function was executed. Key code is a vector of 256 elements, out of which one will be real and the others are false if the key is pressed, or all zeros if nothing is pressed. And delta sex is supplementary information about the interval from the previous KBCheck. We can copy and paste this little loop. I hope it works. And it will do something. And at the end, it plots something. So those are the situations on my keyboard during the execution of this 7-second program. I pressed key 2 times, and the plot highlights that at this time the key was pressed and then it was unpressed. And it was executed 100,000 times during this interval. This is how you have to exploit KBQueueXXX. KBWait, as it is clear from this name, waits until something happens, and you can do nothing until the key is pressed. So this one basically will wait until I press, and then it will give me a delay between the start and the key press. So the delay is 3 seconds and a half. This is an important sum function if you wish to disable some keys on your keyboard. And sometimes you want that no characters are entered in the command window during the execution of your script. If you want to do this, at the very beginning of your script, you write something like listen char2, but don't forget at the end to disable this muting of the keyword entry in the command window with listen char1. In addition to this, you can disable specific keys during your program. For example, you may wish to disable everything except 2 keys, so that those keys are not acquired at all. And how do you know the names of the codes which correspond to a certain key? There are specific functions for this. Let's find out what is the code of the letter of the key corresponding to the letter D. We use this function keyBname, and we ask for D. It is 68. This is the code for this key. And you already know that when the functions tell you that key 68 is pressed, it is key D. For us, might be interesting to know that the down arrow is 39 and up arrow is 38. And if we want to disable them, then we run this function and we indicate the indices of the keys that we wish to disable. KBQ, in my opinion, is the most useful of all of the keyboard functions because it is the most precise of all, and it allows actually to do experimental mental chronometry, to measure reaction times. The outcome is very simple. First, it indicates whether something has been pressed or not between the KBQ start and KBQ stop. Then it indicates which key was first pressed. It is again in a form of array of 256 elements. first released key and then last pressed and last released key. So if you pressed only once, you are interested in those only. If there are two key presses, erroneous and the right one, let's say, then you might wish to control for both of them. After this, in order to start new acquisition of the keyboard, you run keyboard QStart. Here I would like to share you a little sample of the code which illustrates how to use KBQ family to measure a simple reaction time. First of all, we want to concentrate on two keys as a keyboard, arrow left and arrow right, which have the codes 37 and 39 respectively. In order to make the function listen to only two keys, we create this array of zeros. It looks like this. And then we assign to the 37th and 39th element of this array the values of 1, 37 and 39 now are equal to 1. This is necessary for using as an argument for function KBQueueXXX with this kind of syntaxes. To create the object of the queue. It is not visible in the workspace, but it is already created and ready for usage. Then everything starting from here to this point is actually our program to measure reaction times. A single reaction time. Let's read this program line by line. First of all, when we started, we ask Psychtoolbox to wait 1 second in order to make all the keys of the keyboard to be unpressed. The default state is no key is pressed. Then this MATLAB function disp shows us this character, letter A, on the screen in the command window. This will be sort of the onset of the stimulus, to which we will have to reply with a key press. Remember, we will get any key press detected only if we press one of those. Other key presses will be ignored. Afterwards, immediately after display of this character, we measure the current time of the internal MATLAB clock, and we store it in this variable sex. Then we start acquisition of the queue, and it will last as long as we need until we run KBQStop. We let it acquire the status of the keyboard for 5 seconds. Wait sex will make our program wait for 5 seconds, which is more than enough for any kind of reaction time response. Then we execute this critical function KBQCheck, which will tell us whether something has been pressed, and will give us the code and the time of the key press for the first key and for the second or the last key, if at least two of the keys has been pressed during this period of time. And at the very end, we execute KBQueueRelease in order to release the resources which are used to maintain this object in the working memory of the machine. And the last line allows us to measure actually the delay between the display of this character and the key press. Let's execute the measuring part and then look at how this simple computation helps us to measure quite precisely the latency of the key press. So now we paste this script. Now we have letter A, and I press a key. It will be something like 2 seconds of a delay, I think. And now let's look at this array, which is generated by KBQcheck. See, it is here. It will be 256 element array, like this. Most of them are zeros, but one of them, I think it is 30, 33, 34, 35, 37, which is the left arrow, gives us a certain number. This number corresponds to the current time in milliseconds of the internal MATLAB clock. So first we need to identify where this element is located in this array, and then simply subtract the time of the onset of the stimulus from this value. With this simple expression, we easily select just the element of the array which is greater than a 0. So first we set this condition, which will give us a logical array highlighting just the element which is greater than 0 as true, and all the others will be false. And it will select a single element of the same array and give us its value. So here it is, just fine. And now we subtract this variable from achieved value in order to know how much time in milliseconds elapsed between the two time measurements. Well, I was wrong. It was in fact not 2 but 3 seconds. Anyways, here is our measured reaction time. Let me summarize the functionality of the functions used to acquire keyboard. This is KBCheck, which has to be started many times in order to track the state of the keyboard. And then this kind of square response given we know the frequency and the time of each iteration, allows us to measure the time of response during the stimulus, let's say. But here we have to interrupt because we need to stop the stimulus to be present on the screen. This is how can we use KBWait. We start KBWait at the very beginning of the stimulus. And then as soon as the key is pressed, we can continue with our script, and typically here we can stop the stimulus. Some experiments with this kind of design, others not. If you wish to keep fixed duration of the stimulus and to acquire key presses both during the stimulus and after the stimulus until certain deadline, it's better to use KBQ family. First KBQ start and then KBQ check when you decide it is necessary. And whenever is the time of the response, you get it at the end. There are important limitations of the feedback devices, and typically it is about 10 to 20 milliseconds. If you really need 1 millisecond resolution, then you need either to buy a dedicated device which gives you necessary resolution because it is acquired often enough, or you can try to use something like a audio card with high temporal resolution and to feed the responses to the audio system of the computer, which is a useful but not that easy solution. If you wish to know more about how Psychtoolbox is using the keyboard, it is good to use KBDemo. It is a very short script of only 253 lines, and those are the Psychtoolbox functions which are tested and demonstrated there.